For problem 5, we're given the following setup as you see in the graph. Because the electric field is to be 0, then we need the both x component and y component to be 0 at the origin, and that means that all of the components for the 3 charges we're going to put on must add up to 0. So at some point, when we find the location for this 6 microcoulomb charge, it has to be on the x-axis as well, because neither of the other 2 charges has a y component. So that means that this Q 6 microcoulombs has to be also on the x-axis. We notice that we can rewrite the electric field at the origin as the electric field due to the 5 microcoulomb charge plus the electric field as a vector for the -8 microcoulomb charge, and lastly as the sum of the electric field as a vector for the 6 microcoulomb charge. And if we assume that the electric field for the 5 microcoulomb is in the positive x direction, then the electric field for the negative 8 microcoulomb charge is going to be in the opposite direction. And because of the distances and the values, we find out that in order for this to equal 0, in order for the vector sum to equal 0, then the 6 microcoulomb charge has to also be in the same direction as the -8 microcoulomb, otherwise we won't get a 0 out of this. So we will say that the electric field is K times the charge contributing to the field over the distance of that charge to the location required squared. And let's say this is the positive I direction. Then for the -8, it's going to be a K times Q -8 microcoulombs over R -8 squared. But now, since this has to be in the opposite direction of I hat, we would say that this is in the -I hat direction, or we could have made this plus sign and minus to begin with. And as we just discussed, in order to balance these values out, we need the charge at the 6 microcoulomb to be in the same direction as the -8 microcoulomb. So this has to be in the negative I direction as well, and we will set that equal to 0. So now we can rewrite this as K, and we can, since everything is in the I hat direction, we can ignore that for a second. Let's say this is the 5 microcoulomb charge over the distance of where that charge is located relative to the origin, plus, minus the -8 microcoulomb charge over its location squared, minus, so this is a minus, folks, the 6 microcoulomb charge over its location squared, and all of this has to equal 0. In the I hat direction, but that's a unit vector, so it's not going to add to the solution in any way, shape, or form. And now, since K does not equal 0, we know what K equals. This implies that this 5 microcoulomb charge over its distance squared to the origin minus the -8 microcoulomb over its distance squared minus the 6 microcoulomb charge over its distance squared has to equal 0, which means that we can say that Q of 6, I'm going to take the microcoulombs away, over R6 squared equals Q5 over R5 squared minus Q negative 8 over R negative 8, or R8 as we called it, squared. I'm interested in R sub 6, so I can say that Q6 over R6 squared equals, this is a common denominator of R5 squared times R8 squared over R8 squared times Q5 minus R5 squared times Q negative 8, which means if I reciprocate both sides, that R sub 6 squared equals Q sub 6 times R sub 5 squared times R sub 8 squared over R sub 8 squared Q sub 5 minus R sub 5 squared times Q minus 8. Or that R sub 6 by itself is going to be the square root of that term, and now we can plug in these values. So Q6 is 6 microcoulombs. R sub 5, we're told, is 3 centimeters. So 3 centimeters squared. R sub 8 is 4 centimeters squared. Notice I'm only taking the magnitude here, not the direction, because we took care of the direction when we had the I-hats before. So this is time divided by 4 centimeters squared times 5 times 10 to the minus 6 coulomb minus 3 centimeters squared times 8 negative 8 times 10 to the negative 6 coulombs. And if I do that, notice that I will get answer in centimeters right away, and I get 2.4 centimeters as my answer. Which, if we go back up, 2.4 centimeters would be somewhere in here as we expected it has to be, and it would be pointing that way, the electric